Good afternoon, all. Respected teacher and my dear friends. Today I am here to present my seminar topic on the probability and statistics subject. My topic is based on the chapter 4 correlation and regression model. So, my contents are linear regression and linear correlation. First of all, we have to look about linear regression. What is meant by linear regression? Linear regression is an algorithm that provides a linear relationship between an independent variable and a dependent variable to predict the outcome of future events. That means that it is a linear relationship between an independent variable and a dependent variable. Independent variable is also the predictor or explanatory variable that remains unchanged due to the change in other variables. That is, independent variable doesn't change, and also it gives as a role of a predictor. If we have an independent variable, we can predict the dependent variable. The dependent variables, that means which depends on the another variables, change with their fluctuations in the independent variable. The regression model predicts the value of the dependent variable, which is the response or outcome variable being analyzed or studied. The regression model will be predicts the dependent variable values. For example, a tree's height, it is an independent variable which affects the number of leaves in it has. That means dependent variable. So that is the difference between independent and dependent variable. This method is advantageous when at least two variables are available in the data. For example, as observed in stock market forecasting and portfolio management, scientific analysis, etc. This is a fit line. This is an image of a fit line. Here the line of regression is given, and on the y-axis an independent variable is given. The dependent variable is plotted on the x-axis, and the data points are given or as in blue dots, that is data points. In the above figure, the x-axis gives the independent variable and y-axis gives the output or dependent variable. The line of regression is the best fit line for a model. That is, line of regression equal to is a best fit line for a model. A line is plotted for the given data points that suitably fit all the issues. Hence, it is called the best fit line. The goal of the linear regression algorithm is to find this best fit line seen in the above figure. Now we have to move on a question related to this topic. The question is, obtain an equation of the line of regression of yield of rice on water from the data given in the following table, which shows the amount of water applied in inches and the yield of rice in tons per acre in an experimental farm. Estimate the most probable yield of rice of 14 inches of water. Here, this is a table which gives the water and yield data. Now we have to obtain an equation for the line of regression. So let's move on to the answer. We will need to use a linear regression to find the equation of the line of best fit. So we have to find an equation of the line of best fit. So since the provided answer gives the equation in terms of y, we will solve for that. So our first step is calculate the means of x and y. This is the x. X value means which plot on water 12, 8, 24, 30, 36, 42 and 48, and y means which applied on the yield of rice y 5.27, 5.68 likewise. So The means of x and y are the x bar, which gives the answer of mean of water applied. That is adding the 12, 10, 24, 30, 36, 42 and 48 and is divided by the number of data given, that is 7. So we will get the answer 13. And at the same way we are doing on the y bar equal to 5.27 plus 5.68 plus 6.25 up to 8.42, the all divided by 7. We will get the answer 7.08. Then this next step is to calculate the sums of squares and the cross products. We have to calculate the following sums, that is the summation xi. Xi means the individual data points of in the x-axis, that is 12, 18, 24 likewise. And yi means the individual data points that is given on the y-axis or yield of water. Okay. Then xi minus x bar, the all square gives summation of xi square minus the summation of xi square, the whole square divided by n. Likewise, 3 equations are there. Now we have to solve these equations. For that, xi means the summation of x 12 to 48. We will get the answer 210. And likewise in the y, we are adding 5.27 to 8.42. This summing up all these values and we will get the 49.56 as an answer. And then the next xi square means we are squaring the values of x. We are first of all we have to sum up all the values of x squares and adding on that. After that we have to find the square. Likewise in the y-axis also, that we will get 7000 and yi square gives 352.66. And after that we have to multiply the xi and yi, not taking squares, which gives 1477.66. Now we have to substitute these values into the formulas. These 3 formulas, we will get this answer 710.67 and approximately which equals to 17.02 in the third formula. And the third step is calculate the slope b and y-intercept, that is a. The slope b and a, that means y-intercept of the regression line, are calculated as follows. B equals to xi minus x bar into summation xi minus x bar into yi minus y bar, the all divided by summation of xi minus x bar. We will get the answer approximately equal to 0.1. And the same way there an equation is applied. A equals y bar minus b into x bar, which gives approximately equal to 7.08 minus 0.1. We are applying b. We are giving the value of b in this equation into x bar. X bar means 30, which gives 4.08. Then the step 4 is writing the equation of the regression line. The equation of regression line is y equal to a plus bx. That is, y is approximately equal to 4.08. That means the value of a here is given 4.08 plus bx. B, we will get the answer 0.1 into x as in the equation. So first step, our final step, estimate the yield for 14 inches of water. That is, substitute x equal to 14 into the equation. That is, y equal to 4.08 plus 0.1 into 14, which gives 8.08 tons. That is the final answer. Then, correlation. What is meant by correlation? Correlation refers to a process for establishing the relationships between two variables. We have learned a way to get a general idea about whether or not two variables are related. is plot them on a scatter plot. Okay, we will plot them as on a scatter plot, establishing a relationship between two variables. That is, that two variables are not related. Okay, then we will plot them on a scatter plot. While there are many measures of association for variable which are measured at the ordinal or higher level of measurement, correlation is mostly approached. Most commonly approached method is correlation method. And the scatter diagram doesn't give a mathematical value. These are the examples of scatter diagrams. The strong positive correlation gives the line which gives to above x and y axis. It doesn't come back to the down portion. It will give in as it is positive correlation, it will goes up. And the weak positive correlation, that is the dots are scattered and it gives at the part of a y axis. And the strong negative correlation gives to the scatter points are adjointly seen and it is come towards the x axis. And here also the weak negative correlation which comes towards the x axis, and the moderate negative correlation is given, more dots or scatters are seen, and no correlation where the scattered data points are scatterly arranged. Thank you for giving me this wonderful opportunity. This is my seminar topic. I like to conclude my seminar topic. Thank you and have a nice day.